Okay, connected. And we now should have.
Yeah, we're showing up as live, but still with a black screen.
Shouldn't have a black
And
screen.
there's our logo. Okay, so let me just check that we are actually streaming
Mm,
and that our URL hasn't changed.
the URL has changed.
Oh crap. Oh crap. Oh crap.
Why? I'll just edit this page.
Okay, so I need to delete this somehow. Hmm. Okay, stand by, stand by. I need to fix this. I need to fix this. How do I
Why?
fix this?
I can
Let's
just
just
change the URL up there.
this one goes into the bin. Confirm, confirm. And here's
Okay.
hopefully the new URL. Yep. Link, copy link. And okay, I gotta go back to the wiki and update the link accordingly. And let's just hope our streaming won't break in the meantime. So here we go. Link. And the other wiki. Edit. Paste. And back to the chat room.
Okay, so if this works, I'll just start it locally on my machine.
Okay. All right. I guess the situation should be stable now.
Hopefully.
We have a stable live stream, a very good connection. So let's get started. This is once again X2Go, the spread 2024. Winter is coming. Welcome everybody to the last installment of X2Go, the spread, unless we experience another pandemic situation. And as I explained yesterday already, X2Go, the spread will last from Monday to Friday and take place as an evening-only event. So each day we will start around 2000 CET and intend to wrap things up by 2200 CET. Please note that the schedule for the next few days is still subject to last-minute changes, so keep checking the wiki for updates, please. Today's agenda consists of 3 items. The first is a demo of a portable DHCP proxy for netbooting X2Go TCE and other things, followed by 2 presentations from Mihai, where he will be reporting on the progress of KDrive on the ARM64 platform and on his behind-the-scenes work on our PowerPC platform-based virtual machines. So let's start with a portable DHCP proxy demo. And well, we'll not start with a demo. We'll start with some basic and background information about it. Stuck here. Hold on. My presenter is acting up. Sorry. So as a forward, there are a few things to avoid, and this is multiple authoritative DHCP servers that don't know about each other and are active on the same network. That is a really, really bad constellation. The Ghostbusters never cross the streams kind of bad. Do not run this. Do not attempt to run this because you won't be able to. Most DHCP servers are set to authoritative by default. So avoid plugging a second one into a network with an already active DHCP server. Side note, it is possible to run two authoritative DHCP servers on the same network for a load balancing setup or a failover/high availability setup, but they need to know about each other. So using a failover peer primary secondary configuration setting in ISC DHCP server, or the use of libdhcp ha.so in KDHCP server. But this is not what today's demo will be about. Now, a DHCP server has some common tasks, and the main one is to distribute network configuration information to its clients. The bare minimum for this is an IP address and a network mask. Common additional information provided is a default gateway IP, one or more DNS server IPs, and maybe the client hostname to use. Some less common tasks are a distribution of additional routes, NTP server IP or IPs, and quite a lot more options that are available actually. And it can also distribute configuration information that is required for a pre-boot execution environment, or shortly known as PXE. This is also referred to as net booting or as diskless workstation mode. So for this, you will need a next server. That's the server from which the boot file will be downloaded, and a boot file name. There are also further options that may be distributed in a PXE setup, but these two are the ones that you will always need. All of this may be provided dynamically. So for example, depending on the reported client hardware type, say legacy or EFI boot, Intel or ARM64, or even based on the MAC address or parts of the MAC address. Now, what's the difference between a DHCP server and a DHCP proxy? A DHCP proxy is unable to function without an actual DHCP server on the same network. It is able to provide additional information that actual DHCP server did not provide. So this seems to be limited to netboot and PXE data from my experience. So you cannot add, say, additional routes that way. So its role is a perpetual servant. It will not attempt to overwrite the information provided by the actual DHCP server, but it will add or amend what the DHCP server left open in its reply. So that way, it will never cause conflicts unless your DHCP server is already distributing PXE configs. Now, a regular DHCP server or regular DHCP proxy, this is usually either embedded in a small office, home office router appliance, like in Germany, the Fritzbox or Speedport devices, or is a dedicated box or virtual machine in a data center somewhere. It requires a static network configuration because it needs to know which IP to use for itself, and the pool of IPs it is supposed to distribute to its clients. This is for the DHCP server mode, or the network range it is supposed to cover in DHCP proxy mode. And it also needs to know which additional information to supply to clients, like explained in the previous slides. It may be a do one thing right type of executable that acts as a DHCP server and nothing else. This is what ISC DHCP server does. Or a jack of all trades type that also has TFTP and DNS caching capabilities built in. This is what DNS mask does. And we will be using DNS mask for our DHCP proxy. We will disable DNS caching features. This is one line in the config file, port equals 0. We'll enable DHCP proxy mode. I've shown here what the usual configuration for DHCP server mode looks like, and below you can see how you have to change it for DHCP proxy mode. This is assuming a net mask of or 255.255.255.0. We will also need to enable TFTP server mode, which is needed for netbooting and PXE. You can see the two lines required for this here. And the second one specifies where we will be placing our boot files. Okay, so it seems I forgot to delete this from the previous slide. So we will be using iPXE for our netboot and PXE environment. The pros for this are it's more flexible than PXE Linux. It is less complex than grub2, and it will work with EFI and legacy boot environments. The disadvantage is it won't work with secure boot unless you set up and deploy your own keys. So iPXE, or no, not iPXE, but DHC, DNS mask will automatically add tags for the machine type. So if the client that's connecting is either a x86 PC, or which means it's a legacy boot machine, or is an x86-64 machine, this is for EFI, we will be able to distinguish these by tags provided automatically during the boot process. What we will need to add is another tag, iPXE, which will be set if the client identifies as an iPXE machine. Now, if this tag has been set and we are in legacy mode, we need to tell iPXE where it can find its config. And this is a file called autoexec.ipxe. If we were booting in EFI mode, iPXE would automatically search for this file unless we specify a different one. If the tag iPXE has not been set, then we will start showing a prompt. So the user has 5 seconds to press F8 for a menu, or it will proceed with a default option, which is the first one in each list. So in legacy mode, we offer standard iPXE. We also offer UNDI only KPXE. This is for machines where the iPXE does not support the network card. This will only replace the actual boot code and not the full driver firmware. We also offer an option to abort the PXE loader and continue with local booting. And we will do the same in EFI mode. The files are just named a little bit differently there. Now, we need to download the PXE, KPXE, and EFI files mentioned on the previous slides and place them in our TFTP root directory. And these files can all be downloaded from https boot.ipxe.org. And the autoexec iPXE file is a simple text file containing our boot menu. And we need the following minimum entries in our autoexec iPXE that you can see here. The first block is the defaults. And then there's a very, very minimal boot menu with just 1 or 2 options to choose from. Well, one will boot X2Go TCE Live, and the second one will exit the PXE loader and continue with local booting. It will then count down. We have set a timeout of, let me see, 5 seconds.
5 seconds.
And after 5 seconds, it would perform an X2Go thin client boot. Now, we also still need a web server. Lighty will work. Mini HTTPD is even smaller. Just make sure the root directory is the same as the TFTP directory. And this web server can run with IP and port set to 4x0 and port 80. There's no harm done with that in any network you connect to. So this whole setup until now is still pretty static rather than portable, because yes, the web server will bind to port 80 of whatever IP we are assigned, and the iPXE setup uses variables like proxy DHCP server for its own IP. But it turns out a DHCP proxy can run just fine in a DHCP client mode. So you can assign the actual client IP via DHCP to your DHCP proxy device. But two problems remain. One is how to decide when to start the actual DHCP proxy service. Like I said earlier, we don't want to start it if the main DHCP server is already distributing PXE information. And how to make sure that the configuration matches the network it is connected to. So solving problem number one, a DHCP client can be told to request further information, like the PXE boot file name, which normally is only requested during boot. And so if we change our DHCP client to request this boot file name and it gets a reply to this question, and when it does that, we will find it in a log file, then we have an indication that the present DHCP server is also acting as a PXE boot server or providing information for PXE boot. So in that case, we block DHCP proxy startup by intentionally messing up its configuration file. For problem number two, there's a tool called ipcalc. And with some bash magic, we can calculate the network ID from the IP and netmask we are being assigned by the DHCP client. So we need to disable DNS mask's automatic start. We need to stop DNS mask. We need to patch the DNS mask config to either the network ID that we found or to an invalid value so it won't start. And then we need to start DNS mask if it is deemed safe. So we have detected there's no other DHCP server on the network that already distributes PXE boot configuration. And we need to do this every time the network configuration changes. So a script in etc network if upd is the place for that. Yes, I left out a lot of details, and that is because there might be a German language article with more details soon, possibly on Heise Online and or in CT. And showing all details would have meant a lot more text-heavy slides. And there's also more fanciness to come. So this was just the bare minimum what we can do with the system. But we have screen output, audio output, and that's why we'll start the live demo. All right, so I guess I should stop the screen sharing for a moment. Let me just switch to over here, click. And now, this is our little boot server. And I'm guessing the screen might be too bright. So let's see if I can turn off my background light and maybe you can read better that way. Okay, so no,
nope, it's just
too bright, I guess.
It's too bright.
So basically, this is a text console that has a green background because the server has booted and has detected there's no other DHCP server and no DHCP proxy or PXE boot information on this network. So it switches the background of this text console to green and writes out in banner letters, this boot server is enabled, as well as its IP. So at the moment it says this boot server is enabled and the IP is 192.168.1.66. And now you might notice that there's one cable that you wouldn't normally expect on a Pi 4. It's an audio cable. And this is because I have a sound system below my seat here. And if I unplug this server,
interface ETH0, link is down.
It will also tell what's happening. Now it has also changed the screen background to a teal, light blue, something like that, and it's starting to flash in red. Now if I plug it back in, takes a few seconds.
This boot server is enabled. 192.168.0.0.1066. 192.168.0.0.1066. 192.168.00.1066.
And the LED color has switched to a solid green. If the main DHCP server on this network would already provide PXE boot information, the screen background and the LED would switch to a solid red. So I have prepared a laptop and I will unplug the network cable for the first run. So this is what this laptop looks like when it's booting from its local hard drive. You can see a X Linux boot screen, and I'll turn it off. And plug in the network cable. And now we have a DHCP boot server detected. This is the prompt where it says I could press F8 for the menu. And now iPXE is starting the auto-exec PXE file. And this is a bit more fancy than what I showed in the presentation. So this will output, let me see if I can somehow get this on the screen.
Well, you can't really see it because it's too blurry.
So it says this is auto-exec iPXE from your DHCP proxy TFTP server with its IP 166 at the end. DHCP server is, next server is, this client has IP/netmask, the MAC address is, the default gateway is, DNS is, and it's running in PC BIOS, so legacy mode. And if you were to boot it in EFI mode, it would switch and display the proper configuration for that. And now we have several boot options to choose from. This is a MAC address matching, so it would default to our Mate Mini desktop. I can manually override this and select the classic X2Go TCE Live full screen mode. But I can also boot a Debian Live bookworm image, either the minimal console only image or an XFCE desktop, which should run locally. Or for example, I could start X2Go, not X2Go, but CT Disinfect, which would not be a smart idea on this machine because it requires at least 16 gigabytes of RAM, and this one has only 8 as far as I remember. So we'll stick with the full screen mode. And this was the kernel booting, the initial RAM disk, and now it's attempting to download the SquashFS image. And you can see it only takes about 4 or 5 seconds on a gigabit network. Now the complete image has been loaded to the RAM, and it's running off a RAM disk. And as you can see, it doesn't take much longer. We have our blue background, and here's our X2Go Thin client. Let me see if I can get a better view of this for you. No, it's too bright, I guess. Maybe I can reduce the screen brightness on this thing. No, that doesn't work.
Your camera just turned off. Well, okay, it's back. Okay.
Well, shut it down and reboot it in Mate Mini desktop mode, so you can see how long that takes.
Video has been turned off to save bandwidth.
Oh, that's not good.
And now it's back.
Okay, so we are booting again.
And your video is gone again. Okay.
Oh. Okay, so is my video back?
It's back, yeah.
Okay, so now we're booting Mate Mini desktop. Kernel boot, initial RAM disk. and the SquashFS loader. This one is supposed to take about 10 seconds. Yep, 10 seconds and go through. And now everything is back in the RAM disk, and we are running straight off the RAM disk. And there's our desktop with X2Go client occupying the right half of the screen, and our options to choose various browsers from the left side. And we'll let's see if it actually does shut down. This is why Mate Mini Desktop is still in beta, at least in the live version. Okay, and we'll start again. And this time I'll pick the standard Debian Live bookworm image in minimal, so console only mode. This has about 13 seconds of boot time or download time for the SquashFS. And there's the console. So Debian Live images default to auto login in console mode. If you ever manage to log out, or if a user and password, the default username is user and the default password is live with a V. So sudo power off, and this should shut it down once more. Yeah. Oh, that went fast. And once more, we'll boot the machine. And this time I'll press F8 so you can see the boot options we have. So standard, iPXE, or the UNDI only. Let's see what happens if I use that. Okay, works fine on this machine. So let's now try the Debian Live bookworm image with a full-blown XFCE desktop. Again, username is user and password is live, should you ever need it. And this is obviously a bit of a larger image, so this will take about 23 seconds to download. Again, we're doing this all with a gigabit network. So if you are on a slower network, on a 100 megabit network, all these load times will increase by factor 10. And this is also the reason why we recommend using a Pi 4 or Pi 5 as a PXE boot server and DHCP proxy, because those have full gigabit support on their Ethernet network ports. The Pi 3B Plus had nominal gigabit support, but only reach speeds of 300 megabits per second. And all older models are limited to 100 megabits per second. So this should not take very much longer. There's our desktop. We're getting some notifications and it's asking me if I want to use multiple screens. No, I don't. Please close. Please go away. So this is a full XFCE desktop with all the applications you would expect. So there's LibreOffice, there's a browser, and this is now running locally. This is not related to X2Go anymore. This is not a remote desktop. This is a fully local XFCE desktop. Let's shut down once more. And this time, just so you can see what happens, this time I'll leave the network cable plugged into the laptop, but I'll unplug our boot server once more.
Interface ETH0. Link is down.
And now I'll try to boot this machine. And just as you saw before, when the network cable wasn't plugged in, it will not receive a DHCP Pixie boot configuration because there's only a regular run-of-the-mill appliance that's connecting my DSL connection with this laptop. So the classic, like 50, 75 euro DSL router that you can buy in each or in any electronics store. And yeah, as you can see, it will try to connect, but it will time out. And yeah. So one last thing to try or to demo is what happens if I plug in this DHCP proxy into a network where we have a DHCP proxy, DHCP server with a Pixie boot configuration installed. So I'll just unplug this device here, and it should now complain as soon as it detects the connection.
This boot server is disabled. 192.168.0.0.0.195.
So
192.168.0.0.0.195. 192.168.0.0.0.195.
So once again, the screen has turned red. I hope you can see it. The LED has switched to solid red as well. And it does announce its IP because it's reachable via SSH. So you can SSH in, do things with it, but you cannot and should not start a DHCP proxy in this situation. I have done it manually in a test environment, and the results were, let's say, very interesting. So basically, it seems to depend on how physically close your connection is to this rogue DHCP proxy when it's engaged to the actual DHCP server that deploys a Pixie boot configuration. So if you're connected to this switch like we are, and you plug in here while this rogue server is plugged into the switch, you would likely get the configuration from our rogue server, while the machines further down the network in a different switch would probably get the DHCP configuration or the Pixie boot configuration from the actual server. Okay, so that was the demo part. Let me just share my screen again. So what is this good for? Well, this is good for a quick and easy demo or temporary deployment in a SOHO, so small office, home office scenario, where you have an off-the-shelf router appliance that doesn't support Pixie boot configuration. It's also useful if you want to do a demo or temporary deployment in a larger company that does not use Pixie, but can't make quick changes to their DHCP server. So let's say the service is outsourced, you need to file a change request, you need to do the change or to apply the change in a certain maintenance window, stuff like that. And I think it's also useful for disaster and ransomware recovery. So you have a disaster scenario, either your machines have been ransomware and encrypted, or you have some kind of natural disaster, your server room is in the basement and it got flooded, something like that. You spin up a cloud server, which can be a Linux machine with X2Go on it, or a Windows machine with RDP on it. You need to make sure that your network infrastructure is clean. So yes, hackers have been known to hack into the switches and routers, so check for that, or simply replace them for the time being with some cheap gigabit switches from the nearest retail store. Disconnect all client hard drives and add this boot server to go to the network. And bam, you have a fully remote desktop environment that doesn't need any local disks in your client. Now, what else is this good for? What else could this be good for? Well, in addition to X2Go TCE Live, you could boot, like I've shown before, the regular Debian Live image with a full local desktop, and so you can use it as a diskless workstation. You could boot a minimal Debian Live image, also what I've shown before, the text console only mode, and use it as a rescue system. You could boot a modified Debian Live image that spawns an SSH and or NFS server with your SSH public keys baked into the image. Now, this can be used as a remote rescue system, which even works across firewalls if you include a Tor server into your image, and also as an NFS root that can be mounted by a more powerful machine for remote virus scanning. So let's say you want to use Disinfect. This requires a host computer with at least 16 gigabytes of RAM. So if I wanted to scan this old laptop, which only has 8 or 4 gigabytes, I'm out of luck. I would have to physically remove the hard drive, insert it into the more powerful computer or into a USB enclosure and scan it that way. If you have a gigabit network connection, you could boot this image and simply export the root file system as an NFS share and scan it that way. So recommended further reading or actually viewing my presentation from last year's the spread. This was titled Booting X2Go TCE Live with iPixie in EFI and legacy mode. This explains all the basics regarding iPixie and X2Go TCE Live boot. So if you want to learn more about this, just follow this link. Thank you for your time. Now I see we don't have much of an audience tonight, so I guess there won't be any questions unless Mihai has some pressing questions.
Nope.
I guess that was a nope. So up next, we'll do a short break, and after that, it's time for Mihai's progress reports.
And I just realized that I probably should have used Chromium instead.
Mihai, do you know how much buffer we should have in our stream?
I don't know.
Because in my live preview window, we are still at the
Yeah,
solving problem number 1 slide.
Yeah. What? Solid problem number what?
solving problem number 1,
Yeah.
how to decide.
No,
blah,
we
blah,
are
blah.
on short break now, give or take. I mean, we are even much more live. Yeah, I mean,
Well, it says live. And I can see that my head is bobbing around in that little preview window. So
yeah, no,
it's
that's
not
just your
locked up.
browser that is. Yeah, it's your browser that is buffered too much. We're not so far off. Okay, but let me use
What
Chromium
happens?
instead, because your video has always disconnected. And as far as I've seen, that's actually a browser issue and not a network connectivity issue.
Okay.
Let me.
Well, my video isn't that important anymore because the
Yeah,
next 2
but your
talks
video
are
was
yours.
important while you were doing the presentation and while you were showing stuff on, all of this. So that wasn't great. Whatever.
This is interesting. Why is this thing lagging so much?
I don't know. Your system.
Well, if I connect a new browser window to the stream, I'm seeing the same that you're seeing. So the short break slide, while the video, the studio YouTube.com link with the video preview and where I control all of the live stream stuff, this is stuck at or is currently at solving problem number 2. So I don't know, maybe 5 minutes behind.
Yeah, that's too much because probably your browser can't decode as quickly as can do the other stuff. Anyway.
I would have expected it to just drop frames, and keep up with the presentation.
Okay, let me no.
Okay.
Let's finish. Give me a few more seconds.
And I should probably shut this down.
Into KDH0. Link is down.
Okay. Link is down. Audio off. Hi4 off.
The screen will probably see.
This should be.
Okay. And we're now switching to the other browser if I can. Oh, I can't switch. Ooh. Oh no. Uh-oh.
Uh-oh.
Uh-oh. Yeah, I can't seem to be able to switch to Chrome. Wait. Uh-oh.
Uh-oh.
Look, Adventure Chromium. Okay, no, it works. Okay, great. We just put this into full screen mode and oops. Change a few more settings. That's probably working better than Firefox. Hopefully. Okay. Yeah, video stuff is still working fine. We're still streaming. We're still doing stuff. And I've switched over to Chromium, which hopefully.
Ah, gotcha. Alrighty.
Yeah, but it doesn't seem to be capturing it correctly. can capture Firefox. I can capture Chrome. Oh, yeah. Ah, it's working now. Okay, great.
Well, maybe you would. Yeah.
Maybe I should. I would.
I wanted to suggest that you switch to full screen mode, but it seems that you did.
Yeah, I switched to full screen mode.
All right. So, are you ready to start your presentations?
Not yet.
Pardon?
Not quite yet. Give me
Not
another
quite
minute
yet.
or two.
Okay. Sure. In your own time, Mr. Moldovan, in your own time.
Okay, fine.
All right. So, did you prepare slides for this? Do you want to share your screen?
Neither.
All right. So,
Just keep your slide on if possible.
okay.
Yeah, because it's not really interesting anyway. And the person that well, not that I need, but that I will mention is not here anyway. So yeah.
Okay, the stage is yours. Feel free to turn on your camera.
Yeah, no. I'm gonna do this without camera. Okay, so basically, Stefan wanted to have KDrive builds for Raspberry Pi, and especially for newer Debian newer versions of the Debian operating system, including ARM64 builds. We didn't have that before. We did have ARM32 builds or ARM HF builds, which stands for hard float. But these builds were only working for like Buster and maybe Bullseye, but even Bullseye had issues. They certainly didn't work for Bookworm because the mechanism that we used to build packages just crashed on Bookworm and even Bullseye, as far as I remember. So basically, Buster was the last version we were able to supply with builds, and also only with ARM32 builds. Now, we're basically building ARM packages with the QEMU user mode emulation, which is not a full system emulation, but is only emulating a different CPU architecture on an as needed basis transparently via bin FMT MISC. So whenever a foreign arch binary is being started on the system, it's actually diverted to a QEMU static binary that translates the code within the binary into code that can be executed natively on the machine. And this is very, very, very well easy to set up. It's working quite well for most stuff, and it's also quite lightweight because you don't have to run a full VM, including a special kernel or something like that, or you don't have to spawn a different operating system in a VM, right? So because we're just using the normal Linux kernel of the host machine, and what is happening is that QEMU only translates the binary instructions directly and transparently. And this can work faster than a full system emulation, of course, and it's very easy. It does make sense to use it because you can use it very easily. So while that works great most of the time, there are problems with user space or user mode emulation because it does require you to have a pretty recent version of QEMU because the interface that the kernel uses and the interface that QEMU implements change quite often. And that means that using older QEMU versions to emulate binaries that use like newer kernel stuff, IOCTLs and things like that, or use different kernel structures, usually fails at some point in time. And our issue was that our build machine is still based on Debian Stretch, which is very, very old by now, and it's also using the QEMU version that, well, I'm not quite sure if you're using the QEMU version that came with Stretch or whether I've actually switched to the Stretch backports version. But in any case, it's been very, very old, and it failed to run to even install the Debian packages that are a prerequisite for building packages. So that never actually worked, or that didn't fly any longer. But because Stefan wanted to have bookworm builds, he essentially donated one of his machines that were running anyway to be used as an ARM build server using the QEMU user space emulation. And that worked fine at the very first glance. It did take me a while to set it up, but that wasn't the huge issue. It did work for the KDrive server build and for a few other packages that didn't actually use a lot of, well, actually GUI elements, because it did fail for all packages that used Qt, and not just Qt, but also QMake. I had to debug this for quite a while and to figure out what actually went wrong there. And I did so. And I also found a workaround, which I have pushed to all packages that are affected by this issue. So that we now have basically a full X2Go suite of packages, even for Bookworm. And I don't think that I added Bullseye packages, but I probably won't because Bullseye is almost dead anyway. But we're now providing Bookworm packages for both ARM32 and ARM64. And the issue with QMake has been that QMake that QMake is using QProcess internally. QProcess is a class within Qt that can be used to spawn processes. And normally you don't use QProcess to spawn command line processes. You only use it, well, I mean, actually you can spawn command line processes, and we do so in X2Go client, for instance. We use it for stuff like Pulse Audio and OpenSSH. But you practically only use QProcess from within GUI programs. But QMake itself is using it in a command line program as well. And this failed badly with the QEMU version that is part of Debian Bullseye. So this took me quite a while to debug, and it wasn't easy because I couldn't reproduce the issue on Debian Bookworm, I think. No. Yeah, I could reproduce it on Debian Bookworm, but I couldn't find out what was happening really. I've had to actually rebuild qmake and debug it and use print debugging and everything in order to find out where it actually crashes. Or it didn't crash. It wasn't able to get to the make spec, which is basically telling it what compiler to use and stuff like that. So it didn't actually crash. It just failed to get some data it needed in order to compile packages or configure packages, not even compile them. And this is failing up to Debian Bookworm, and it's also failing on Bookworm. However, it's working with the QEMU version that is part of Debian testing and unstable, as far as I remember, because this includes a patch that actually fixes that issue. Because qprocess is using an interface that is not implemented correctly in QEMU for older versions. And that's not an issue because I was able to work around it. We do have builds for that now, and we're still using Debian Bullseye on Stefan's build machine. But Mike has already offered to provide access to an actual ARM64 based machine in order to build packages on natively without any QEMU user mode emulation or full system emulation or whatever, which I'll gladly take. I just requested him to set up an LXC container so that I can install packages that I need in order to build source packages and stuff like that. And he hasn't done so yet, so I'm still waiting on that essentially. Now, I can't tell him right now because he's not here at the very moment. But yeah, I'm hopeful that we'll actually get access to this machine and that we can build native packages, or that we could eventually upgrade the machines that Stefan provided to Debian Bookworm and maybe backport QEMU from unstable or
so upgrading this machine or installing Bookworm in parallel to the current installation is something that's on my to-do list, but with a low priority.
But it's difficult to do so. I know, because you do have we can't easily upgrade in place. We'd have to actually reinstall it.
There is a free partition for it, so that's not the issue.
There's a free partition. Yeah, but yeah, so we can only switch
timing issue.
prod. Yeah, it's a timing issue. But the question is, do we actually want to do this if Mike can provide a native builder?
And that's actually something that I would like to ask you about. Now, usually emulation on it is always slower than the original.
Yeah.
Is
a lot
this
slower.
Also true for ARM? Because ARM is usually more of a low power and high performance platform.
Yeah, it's much slower. I mean, I can't tell you how much slower it is, but it is noticeably slower.
The build machine we currently have is obviously a really old machine. I think it's 10 or 12 years old. So that this machine is slower emulating ARM64 commands, that's obvious. But I was wondering if we could get a newer Intel 64 based machine. Would the QEMU emulation of ARM64 on that machine maybe be faster than ARM, or would it still be slower?
No, it would still be slower. Yeah, I mean, your machine. So basically, I mean, I can give you a few data points. So usually, building the X2Go server Debian package takes about 2 to 3 minutes natively on x86-64 on our native builder, essentially, which is a server which is Japsund, Japsund, right? It does have 64 gigabytes of RAM. It has like a quad-core CPU with multi-threading and stuff like that. So it takes about 2 to 3 minutes, and most of that is not actually spent doing compilation stuff, because X2Go server only includes a wrapper that is compiled, a wrapper binary that is compiled. Most of the stuff is just disk I/O, essentially. And the same package takes about 30 to 40 minutes to build on your server, on your machine. So that's a huge difference.
In emulation mode, yeah.
In emulation mode, yeah. So that's a huge difference. And even if you were to upgrade it to something that is, say, 4 times more powerful, it would still take about like 8 minutes, give or take, to build the same package, which is still 4 times slower than the native build, essentially, right? So
and the native build time on Intel is comparable to the native build time on ARM64. Are you sure about that?
yeah. Well, it's mostly IO based, right? So it's mostly based, and we're already using. I mean, we're only using SATA hard disk drives in JetSend. So if that were SSD storage, that would be even faster. And Mike's machine, as far as I remember, uses SSD storage anyway. Yeah. I mean, native builds on ARM64, if everything, if the hardware actually checks out, should be about as fast as a native build on our x86 machine, give or take. But you will never be able to reach these times with Cuba user support emulation, unless, I don't know, the emulating machine is like 100 times more powerful than the ARM machine.
The question is, would more cores help, or is it really only disk I/O?
It's
so
not disk
do
I/O
I need
for
a machine that has a high clock rate, like I don't know how many gigahertz? Do I need a machine with many cores because it is easily parallelizable?
Yeah,
you know what I mean.
not everything is easily parallelizable. No, that's another issue. Actually, NX Ellipse, we can't build NX Ellipse with more than one thread because we do have some race conditions in there which would actually make the build fail if you try to build it with like 4 or 8 threads or anything like that. So we've already had to limit this to only one thread, and that's taking a really long time to build on your machine. Like,
so for that, you would
7
need
hours.
a machine with a high gigahertz number, but a single core.
But I figured that the machine had to be like 100 times more powerful than the ARM machine in order for it to break even. So that's not actually something that.
If you're in the mood and if you have time for a scientific experiment and want to generate another data point, I currently have a Pi 5 on loan, and I have one of those fast USB 3 sticks that you know. And we could install iOS on that one. And I could grant you access to that, and you could try to use that as a build server. So I don't have SATA or mSATA for it, but I have this fast USB 3 stick. If you're interested and have time,
which I don't know how fast it is actually, but well, if it's actually a very fast stick, it can do like 300 megabytes per second.
It's basically the same that you're using in your car.
Ah, okay. Oh, that's
like this Kingston purple black slider thingy.
Okay. With like 512 gigabytes of space or something like that.
Well, it might be a 256 one. I'm not quite sure, but it's the same speed.
Yeah, well, we could be doing that, or we could just wait on Mike to actually provide access to his machine, because I mean, setting it up actually takes time.
That's why I said you need to be in the mood and you need to have the time for it. But if you do have both, let me know.
Yeah. I don't think that it actually makes sense. I mean, it might make sense to do that if we didn't have any other alternative. Right?
So what I can offer you is if this image works both on Pi 4 and Pi 5, which the basic operating system does, but I don't know what you need to add into that. If you have to use some Pi 5 specific code, then that will break. But I do have a Pi 4 that we could use for a longer time, even if I have to return the Pi 5. So your
Mm.
work would not be completely be wasted
Yeah.
if you have to
Yeah.
return the Pi 5, because we could
Yeah,
switch
but
it
it
to
just
the
doesn't make
slower
sense,
Pi
really.
4
Yeah.
until Mike offers you access to the ARM64
Yeah.
machine he has.
Yeah.
That's one
It
option I can offer.
it just doesn't make sense because, I mean, sure, that works, but the build machine actually needs a bit of disk space, as you've seen. We've had issues with that every now and then, and the root file system is already full again.
Oh dear.
So you so you might want to check that. I didn't actually clean it up. It does it's full, but it still has a bit of root reserve on it, so
Yeah,
you can
probably
connect it
5% or
to.
so.
Yeah. But
Okay.
but other than that, it's already completely full. But you know, it only has like 3 gigabytes of root disk space, so that's not very surprising. Now yeah, but I mean, sure, I could set it up, but you know, yeah, I don't see why
Yes,
I would do that.
it's something you can consider to do, or you can
Yeah,
just say
if
screw it.
if we want to have, you know, our own personal builder or you know net project internal builder, I'd rather go for. Yeah, I've already told you, personally or privately. Like, but I don't remember what device I actually looked at. I think it was an Orange Pi 5 Plus or something like that. Um, and the fun part about this device is that it has gigabit Ethernet networking, which is not connected via USB, so it's actually doing gigabit Ethernet speeds too. And it also has or I think 2 M2 slots, which can be populated with a Wi-Fi card because it doesn't come with Wi-Fi pre-installed, which is not an issue because I'd rather have a slot that I can populate with a card rather than, you know, a built-in card of questionable quality, like in the Raspberry Pi. I don't like Broadcom chips, for instance, and they never actually work correctly. And and the second M2 slot can be populated with an M2 NVMe SSD, which, you know, makes it even faster
Well,
and even better. So
well, there are boards for the. You remember this compute module 4 that I'm using with a
yeah,
dual gigabit baseboard?
yeah,
Um,
yeah,
there are other baseboards available for the CM4 that have the features you mentioned.
yeah,
So
maybe, but
using a
these are
Raspberry
still
Pi in CM4
format.
mode or
Yeah,
format, yes,
maybe, but the Raspberry
with a
Pi
proper
still
baseboard.
has, yeah, but it has a worse CPU than what the Orange Pi has.
And you are sure that you can run a stock Debian or whatever on this machine? Because I remember
Mostly
that a
yes.
lot of these clones
Yeah.
a custom built kernel with patches
Yeah.
provided by the
Uh,
manufacturer, and they have a
I don't think that
tendency
they need.
to
Yeah.
stop supporting them after a few generations.
Yeah, maybe. I mean, I don't think that the Orange Pi Foundation would. But yeah, that's a concern. As far as as far as I've seen, um, they are not using a special kernel, but they are using a custom crafted device device tree data, which actually tells the kernel how to access hardware. So,
Uh-huh.
so yeah, because well, in a normal PC, you have the BIOS, which can be used to enumerate PCI devices and everything like that, and can be used for actual boot up and stuff like that. ARM devices typically don't have that. They store this kind of information in a structure that is called device tree, and it's basically a textual representation of the hardware and the ports that and how the ports are connected. And this should work even if you update the kernel, basically.
Okay.
So once you have, so once the device tree stuff is actually working, it should continue to work even with kernel upgrades. So I don't think that that would be a huge issue. Now, the issue is that this costs a bit of money. I guess I came out at about 300 euros. You said that that might be a viable option, especially if we also provide access to this machine for free RDP, for instance, which is part
Yeah,
of
the catch about this is that FreeRDP is
But-
looking for an ARM64
Yeah.
machine to do Mac builds on.
Okay.
So if it's possible to do that with this machine, then yes, we could buy it from that budget.
In theory, that's. I mean, I don't know whether it's actually Mac. Okay, well, Mac is a different beast. As Yuri has already found out, there are ways in which you can cross-compile for Mac. I don't know whether this cross-compilation is working if you are using the native architecture already, or but given that they probably are using just the usual the normal. I mean, I think that they are only using LLVM and Clang, the compiler suite, and LLVM is basically doing the intermediate representation stuff. So that might work even on ARM64 natively, but I'm not sure about that. I've never actually looked into that. I wouldn't, put my, yeah.
Okay, so I guess it makes sense to discuss this in more detail when Mike and Yuri are present.
Yeah. But for X2Go, I'd summarize that, what we actually need is just access to Mike's machine that is, set up anyway. He uses it for building UB ports stuff and packages for UB ports. So I don't see why we shouldn't use it if he gives us access to it. The only gripe with that was that I want to have your root access in order to install packages for source builds and stuff.
Mm-hmm.
But that's doable with an LXC container. Okay. And the second part would be OSUOSL behind the scenes things, which isn't actually so much. I mean, I can't even say a lot about that. The only thing I really did was to convert the current VMs that we use to Power 9 machines.
Both of them or just one?
Three of them, as far as I remember. I mean, both demo machines are P9 now, as far as I remember, and the build machine, and I've also rebuilt the build machine, or rescaled the build machine to P9 essentially. And what I also did was to delete all snapshots that we've had from for like 8 years now, because we've already been using this service for so long that a lot of snapshots accumulated. You said that that each snapshot is potentially decreasing the disk performance.
Yes.
And,
so LVM2 snapshots have a write penalty because each 4 kilobyte block that you access needs to be copied over as soon as you write. And so even if you're only writing a single byte in your file system, you're writing a 4 kilobyte block.
Yeah. But still, I don't know whether this is true for OSUOSL, because we don't know what backend structure they use. We don't know whether they are just using QCO2 files, which should be pretty okay when it comes to snapshots and performance, because you're just diverting new data to a new file. Now it could get slow when reading it back because you'd have to make sure that you're reading from the correct file. But and you know, each block could be in a different file, so you'd have to be you'd be jumping around between snapshot files essentially in order to gather all the data that you actually need. I didn't actually experience, I didn't actually see a performance increase from doing that, and we've also lost data that was important to you. So yeah, there we go.
Okay, so one of the IPs I have in my list for OSUOSL doesn't connect me to the server that I expected. So that's probably still the old one. Let's check the other one.
Use my DNS names.
Yeah, stand by. There we are at this one. Okay, this one still works. Proc CPU info should show what is. Okay, this is a Power 9.
Yep, and the Power 9 machines also have IPv6 connectivity now, as far as I remember. Or
But
maybe I've only changed it for one. I don't know.
I think we should be on Power 10. So this machine is still a Power 9 machine.
No, Power 10 doesn't. Does Power 10 exist already?
Of course.
At OSUOSL?
Yes.
Okay.
We
Okay,
were
so
on
maybe
Power 9 when we
Mm.
started, because Power 9 was newly released back then.
No, we started with Power 8. I'm pretty sure about that.
Are you sure?
Yeah. We definitely started with Power 8.
Okay, so maybe we did one upgrade in between them, but let me see. Which one was it?
Well,
So this was a Debian 11 Little Endian stable demo box. This is still running on Power 9.
It's still running on Power 9. Okay, let me
So
open.
if you have the IP or the DNS name for the nightly machine, maybe you could connect to it and just run a cat what's it cat proc CPU info and see if it's a 9 or 10.
Let me log into the cloud interface.
Mm-hmm.
I mean, I think that's easier than guessing. Instances. So, right. Okay. So, yeah, the nightly demo box should be running P10 NVMe medium, and the stable demo box is still running on P9 medium without NVMe. So I probably should also upgrade this, but we've had an issue with upgrading because you can't really upgrade. Now the issue was that you can't rescale a machine from HDD storage to NVMe storage or SSD storage. That's not a limitation in general of OpenStack. It's a limitation of how OSUOSL of their infrastructure essentially. You can't move images around. So what I had to do in order to switch to the P10 Power 10 machine or cluster with NVMe storage was to actually delete the VM completely and create a new VM with the base image that I've used before. I mean, I can actually create a snapshot of an image and use that as the backing storage for a new image. And I probably have to do this for the stable machine as well, because otherwise it just wouldn't boot up. I've
Yeah.
actually had to request help from the OSUOSL people in order to get it running again. And the nightly machine now has native IPv6 support. All other machines don't have IPv6 support. And the build box is also currently using P9. The very old build machine that is still using PPC64 Big Endian is actually on P8. So we've started with P8 and we've now upgraded to, well, one demo box to P10 and all the other machines are still on P9. I basically have to, continue with that stuff, but it's complicated because you have to wait so long and for it to create snapshots and you'd have to delete it. We'd also lose the IP address that you now have
Yeah.
for the stable machine, but that's not an issue because I can just change it in the DNS. I can
Yeah.
just change the DNS record if you use that.
But when you do this snapshot conversion to base image and reinstall on NVMe, if you proceed like this, you can do it on your own. You don't need Lance for help for it, right?
If I remember what I did back then, yes.
Okay.
Yeah, I think so. Yeah. Well, and even if I need help, I can always ask him to look into this again. But I'm pretty sure that I know the drill now. So
Okay.
basically, I'll have to create.
Once again, it's just a matter of time.
Yeah.
Okay. So basically, we have one machine upgraded to Power 10.
And NVMe. That's the
NVMe.
important part because the disk I/O is way better with the NVMe cluster than with the HDD cluster. And unfortunately, I've also put the nightly demo box with the P10 stuff on a different network segment, hoping that it would actually, that a different network segment would be faster than the one we've used before. And this turned out not to be true, of course. So the network segment doesn't actually make a difference in network speed, unfortunately, especially not for us. Which
well,
is quite
it would have been nice if we would have gotten a lower latency from it, but
no.
Alas, no luck.
Yeah. Well, I can live with a pretty high latency as long as we do have throughput, but we don't even we have neither essentially, at least to Europe. That's a problem.
Well, the latency really sucks. That's the main issue for demoing X2Go with these machines.
Yeah.
And I really wonder if the virtual machines we had before also might have been hosted in Europe, because it was some what was it? It was somehow related to OVH, I think.
No. I mean,
what was it called?
We
So You Start?
Yeah. There was So You Start. That was not OSUOSL. That was OVH. Yeah. But they actually got rid of all PPC power machines, as far as I remember.
And I was wondering if when they still had power machines, if they were hosted in Europe, and if they were seeing low latency because of that.
Yeah, pretty sure. I mean, I think they were hosted in France, like pretty much everything that is being. Well, actually, OVH has data centers in Canada and Asia Pacific now as well, but their main focus is still France with 3 data centers there. They also have a data center in Limburg, Germany, and Helsinki.
Well, Helsinki might have
Poland.
a bit of a problem right now.
Yeah, I don't know.
You didn't watch the news?
No, I didn't.
It looks like there has been a sabotage attack on a fiber connection between Germany and Finland.
Okay.
and
Yeah.
they're suspecting Russian influence because
Yeah.
another Russian vessel was detected on the coast of Ireland, I think, or outside their territorial waters, in a spot where a lot of fiber links, underwater fiber links and telecommunication cables meet. So this might have been a decoy operation. Focus attention on this hub in the waters in front of Ireland, and while everybody's focusing on that, cut the fiber channel or fiber lines to Helsinki.
Yeah, but anyway, OVH
So
does not
actually,
offer any.
our hosting provider Hetzner already has it on its outage report. Their Finnish data center is affected.
Yeah, but Hetzner doesn't have power machines, so
No.
I've actually looked around to look for other hosting options, which could be interesting if the price is competitive and especially if we don't have to keep the machines running when we don't need them, right? So we'd only spin them up for events and then shut them back down. But unfortunately, I couldn't find. I mean, I did find a few hosters, but the prices were
I believe
very high.
I believe power-based hosting with on-demand pricing is available in the Google Cloud.
Mm-hmm. Okay, so you could spin it up,
Yeah,
as you do for your Google console.
yeah. But this is a paid offer. This is not part of the free offer they have.
It's not part of the free plan of the.
So I would have to sign up for it.
Yeah, and that probably doesn't make sense again. So yeah, I don't know. I mean,
Right.
I do like OSUOSL, and they are providing a free server, so I can't actually, I shouldn't I should be thankful for that. I shouldn't complain. I should be thankful for that. But the network performance just is not great. Well, but have you ever tested? Yeah, you have tested the network performance from your Google Cloud account to OSUOSL, right?
From the Belgian servers to OSUOSL, and the latency between Germany and Belgium and the US combined is just the same as if we connect directly to the US.
But was the throughput better? Probably not.
Have
you tested iPerf?
I don't remember testing the throughput. I just remember testing latency, and the numbers added up.
And you can't actually use a Google Cloud instance in the US easily.
Oh, I can. And it's pretty much as slow as connecting to OSUOSL.
Okay. So that doesn't happen.
I think we even did checks like from Germany to Belgium, to the East Coast, to some Midwestern location, and to California. And it's just chopping the latency into blocks. And if you add it all together, it's just the same as connecting directly to OSUOSL.
Okay, so yeah. Okay, so there's no.
Either we're hitting the physical limit.
Yeah, of the transatlantic cable, probably.
Yeah, light speed. Like the connection is traveling with light speed if it's fiber, but the Earth is big, and it needs to go around. It can't. There's no one drilling a hole directly to the Californian side from Germany. So this will take some time.
Yeah, but even with a high latency, you could still get a good throughput out of that. But we're only getting like 200 kilobytes per second, which is not great from OSUOSL. That's the issue. I don't think that the latency is the big factor. But anyway, so okay, going forward, I probably have to rescale all the other VMs too. I mean, but the PPC, but the big endian machine, I'm still undecided on what to do with the big endian machine. Probably turn it off at some point in time because we're not using it anyway any longer. And we're building big endian binaries doesn't make sense because IBM has pulled the plug on
So-
that.
So are we still building big Indian binaries at the moment?
Yeah, in theory, we're still doing we're still building big endian packages for CentOS 7 and
Okay.
very old Debian
And
versions, but
wasn't CentOS 7 supposed to expire or hit EOL
it
this?
already has expired. Yeah. But I haven't set up builds for CentOS or for Alma Linux or what's the other name?
Rocky Linux?
Rocky Linux. Yeah. So that's still
Do you know
all
if
to be
they
done.
are still offering big Indian builds?
They are not offering big endian builds, no. Well, IBM has pulled the plug, and since Red Hat is owned by IBM, why should they still offer big endian builds?
I mean, they have access to the source, so they could build it.
Yeah, but as far as I know, but nobody supports it any longer. So yeah, SUSE has also dropped support for big endian builds. It's dead.
Okay. It's that, Jim. All right. Anything else you would like to add?
I think I'm done.
All right. So, what to expect tomorrow? Tomorrow we'll continue with discussing X2Go's funding situation, this time focusing on Orca, X2Go, and Better Place. We should also look at the ideas we have collected last year on the Wednesday meeting of Spread 2023. Like I said earlier or yesterday, we've shot ourselves in the foot with splitting up the Better Place donations. But maybe some of those ideas would still make sense. Like maybe not as another category, like we currently have 4 donation categories: Orca, X2Go in general, X2Go events, X2Go infrastructure. But maybe we could turn some of them into needs and post them under the general X2Go donation section. So that's something we should take a look at. Then we should take a look at what's happening on our GitLab server. Like, are we up to date with patches? I think there was a security update recently. We should check that this is installed. Are there any things that still need to be done? And after that, if time permits, I guess we should do another round of bug track cleanup. So that's all for tonight. Thank you for your time. And unless anybody has questions or requests for tomorrow, I guess it's time to end the stream and wish you all a good night. See you tomorrow.
Okay, bye-bye.
Mihai, you can stop the stream.